My name is Carmen Aguilera. I'm coming from the European GNSS Agency. We are in charge of managing the EGNOS and Galileo programs, and I will guide you through this session. So our program for today is the one on the slide. I will give you an update on where we are with EGNOS and Galileo and plan the next developments. Afterwards, we'll have a presentation by Christian Böller from Polonia to explain the status of the use of Galileo search and rescue for aircraft tracking and distress tracking. Pere Molina is going to cover the use of EGNOS and Galileo for UAVs, and finally, Hugo Luengo is going to go further to explain how to go beyond the traditional use of EGNOS for approach procedures, but enlarging it to general aviation and non-instrument travelers. So our motivation for this session is to explain you that the evolution that we are performing for EGNOS and Galileo, and also get inputs from your side in case you see or you have the need for further evolution in the programs. We are now in a situation of the programs that we are still on time to include new requirements, and so that EGNOS and Galileo can serve new uses in aviation. So please let us know if there is something we are missing and whether we should include additional requirements. Actually, from all of you know that EGNOS was created for aviation. In fact, the objective of EGNOS was to support RMP approaches down to LTV minima. The situation has evolved a lot. Now also EGNOS is being used for surveillance applications. Galileo is becoming into the picture, enabling now aircraft tracking and distress tracking, and is coming soon to support navigation. Also, there are new entrants in the airspace, such as ARPAs or suborbital flights that are also increasing the use of EGNOS and Galileo, and we are looking into new requirements that may lead to additional evolutions of these flights. As you saw in the title of the presentation, GSA is also offering funding opportunities to support the development of these applications and analyze further needs for evolution of the systems. So I will cover this topic at the end of my presentation. All these new users and new uses is being recorded or is being implemented into new applications, new regulations, so that we are still on time to implement these things. Quick update on where we are with the programs. For EGNOS, you may be aware that we published a new service definition document in October 2018. The coverage of EGNOS has been increased, and you see the availability maps for the IPv1 and MPv200 service levels on the right part of the slide. EGNOS is now providing a service to almost all EU countries, so that makes it possible to implement RMP approaches down to LPV minima, and also Cat1 approaches to almost everywhere. This makes the case also for rationalizing ILS in the future, as it is foreseen in the PBN regulation. But furthermore, we are already working quite intensively in the evolution of EGNOS. So we are working on EGNOS v3. This is the next release of EGNOS that will augment not only GPS but also Galileo, and will provide the augmentation into frequencies. The benefit of this new version is that it is going to provide more robustness, because you will be able to have augmentation into frequencies. The signal is going to augment the two constellations, so that means better availability and also an enlarged coverage area. But where we are with Galileo? Well, you are aware that Galileo is the EU core constellation. Galileo declared the initial services in 2016, and we are moving forward towards the use of Galileo for civil aviation. So the SAPs for Galileo are in progress in ICAO. A preliminary proposal for key performance indicators was agreed in November 2018, and the concept of operations for the DFMC operations was agreed as well. We are now working a lot in the implementation of advanced RAIM. So advanced RAIM is the evolution of receiver integrity monitoring technology that at the moment is enabling mainly LNAV approaches when it comes to approaches, but the new version of ARRAIN that is going to augment GPS and Galileo is aiming to provide Category 1 worldwide coverage. This is a long-term evolution. According to the ATM master plan, that the ARRAIN capabilities planned to start deployment from 2030 onwards, but now the work is focused on prototyping the receivers. We are working with the companies you see in the slide, Rowell Collins, Deimos, Airbus, and Aire DLR, in order to implement the algorithms for ARRAIN in the receiver and make sure that this technology is ready by 2030. But when it comes to use of EGNOS and Galileo, what happened since we gave this similar presentation last year? Well, we normally show you a map of the implementation of EGNOS procedures. There are more than 600 RMP approach procedures with EGNOS operational in Europe today, but the main change was the publication by the European Commission of the PBN regulation that mandates implementation of RMP approaches, including LPB minima, to all runways by 2024. Commission also included a mandate to rationalize conventional procedures and infrastructure by 2030. So that means that we will be in a full PBN environment by 2030, and we expect that EGNOS will be the main technology replacing ILS by that time. Going beyond manned aviation or fixed wing, we also saw during the last year implementation of the first point-in-space approaches. In particular, you may have seen a presentation by Caproni in the Trento region yesterday, who implemented the first point-in-space for helicopter emergency and medical services using EGNOS. And not only that, but also EASA published a proposal for regulation in the all-weather operations group that is targeting the use of enhanced vision system and synthetic vision systems, where also EGNOS plays a role to go below 200 feet minima. A quick overview to the main regulations that were published last year. We said before, PBN regulation is mandating LPB everywhere, but as also you have seen during the presentations of these days, the SPIIR mandating ADS-B has been published as well. As of today, the ADS-B mandate doesn't require EGNOS, so you can comply to the ADS-B auto mandate with avionics using GPS only. However, what we see in the two regulations is that the deadlines are similar, 2020 for the SPIIR, 2020 and 2024 for the PBN regulation. So this makes the case for airlines planning to order new aircraft to consider implementing or buying aircraft which are SBAS equipped from the beginning, so that with a single investment they can be compliant with or be ready for the two regulations. Last but not least, new EGNOS users, and for this I will give the floor to my guests in the session. We have seen during the last year that there are new demands for Galileo and EGNOS services, also mainly driven by new regulations. So you may be aware about the GATS requirement proposed by ICAO that is going to mandate not only aircraft tracking but also distress tracking by 2021. Galileo is the first contributor to the COSPAR-SARSAT MEOSAR system, that is the international system dealing with the search and rescue, and we are working together with the manufacturers, with Orolia, as an example, to implement search and rescue beacons that implement Galileo functionalities. And we are also developing a new service for Galileo to increase the capability and the functionality of distress tracking. Drones are coming very quickly into the picture. Actually, the number of drones in the market is much higher than all the other aviation users altogether, but drone operations require accuracy, availability, and robust operations. In these kind of operations, the use of accurate position enabled by EGNOS and Galileo is a must, but also integrity provided by the systems. And last but not least, general and business aviation are also demanding access to runways where there are no instrumented flight procedures, or where there could be instrumented flight approaches enabled, and Hugo will explain us how we are tackling this need. Last topic about in my presentation is about the funding opportunities. As I said before, the GSA is providing funding options to users that would like to develop new solutions based on EGNOS and Galileo for aviation. We just called a call for proposals 1 week ago, so you cannot apply to this one, but you can already prepare applications for the new funding call that we are going to open at the end of this year. We are opening a new call within the Horizon 2020 program called the Space EGNS 2020 call. You will see a list of topics in the description of the call, and one of them is looking at transport. And within transport, we are looking at aviation. That means you can apply to this call, which has a total budget of 10 million euro and providing 70% funding to develop applications for aviation that use EGNOS on Galileo. And this covers the wide spectrum of applications. So from advanced navigation operations to surveillance, tracking, and drone operations. The call is opening on 5th of November, so you have time to look at it, but if you are interested, it would be nice to start looking at the opportunity. What is new in this call is that we are exploring a new funding option. So normally we offer co-funding of 70% to research and development projects. This is the standard tool in Horizon 2020. But this year we are exploring and I would like to have your views about the possibility of having funding in a different way. It would be funding that is devoted to public entities in order to implement GNSS solutions. So this is what is called innovation procurement. We are thinking to dedicate part of the budget to fund public institutions so that they can implement innovative services based on GNSS, and these services or this request would be subcontracted by industry. So let's make an example. You can see some examples in the slide of possible projects and that can fit under this scheme. A quite interesting example is the case of helicopter emergency medical services using EGNOS. Normally, it is the public entities, the ones that are managing hospitals, emergency services, and the ones that are launching public tenders so that industry can provide them with these services. The idea of this call would be to fund a consortium of European public entities that are in charge of emergency helicopter medical emergency services so that they can contract industry to propose these services. So most of you are representative of industry, and I would be interested to know from your side if you see this as a positive tool or as a possible option for you to get indirect funding through public authorities, and if you see that it would be very beneficial for your business. You see pilot in my slide. Why we are putting pilot is because we are still not sure if we will introduce this topic in the call. So I would be very interested to know from you during today, if you are interested in this, which topics you would like to see in the call so that we can shape it according to your needs. I will give the floor to my guests, but before finishing, just to let you know that after this session, we are going to give the traditional EGNOS and Galileo Awards in the GSA stand, the stand 1141, and we will have a cocktail afterwards, so we will be happy to host you and welcome you in the cocktail as well. So thank you very much. And our first, I will leave the questions by the end because I think we have a tight agenda. And our first presenter is Christian Bellet from Orolia, who is going to explain the use of Galileo search and rescue for distress tracking. I help you. Yeah. Okay.
Good morning. My name is Christian Bellet. I am in charge of the search and rescue at Orolia, general manager of the French facility. So just to let you know who we are. Which one? Ah, this one. Yes, so just a quick summary of Aurelia. Aurelia is a company of about 450 people, 100 million euros, started in 2006, and we grew in acquisition, and mainly in what we call a resilient navigation, positioning and timing, which is really what is needed today to mitigate these threats that we see. We work on the search and rescue ecosystem completely from end to end. So we have the rescue beacons that are showing and sending the distress alerts. We have some atomic clocks on Galileo satellites. And we do also the ground segment, so the the receiver of the distress message, and in fact Mission Control Center, Rescue Coordination Center, to have the complete loop to search and rescue. So in terms of roadmap, we have created and provided the aviation industry with what is called emergency locator transmitters since 1995. We have now, in fact, several generations of beacons, and responding to what is the next challenge in aviation, to cope with what happened, in fact, with the big crashes and disappearance of aircraft like Malaysian Airlines, Air France 447. So the GADS initiative has been created by ICAO to find solutions for that. So we have one project which is called Helios that I will present later, and a very recent one, in fact, Toseti, for a different kind of beacon. So you have two type of emergency locator transmitters on an aircraft, fixed and portable, and this covers the two. And this is really typical installations when, so to visualize what we are doing, orange boxes, emergency. So you have the one in the middle on the aircraft, which is a distress tracking emergency locator, which is sending a message automatically by the analysis of flight parameter, and this is new with GADS requirements. This is an analysis of the flight envelope of the aircraft in flight. So previously that was at a crash. So that's too late, really. So this is what is new. And the portable ELT, also, in fact, survival ELT, which receives the RLS, so return link service from Galileo, and has improved performance for that, also meeting all the lithium requirements. Part of the package, part of the Helios project, we have also maritime and land, in fact, a personal locator beacon included. And in fact, this is the complete setup and complete range of products that we provide at Aurelia. So the first project, called Toseti, is really to validate the search and rescue system in the field. This is a distress beacon which is in the cabin of the aircraft for the crew, and in fact is activated and put on the water when an aircraft ditch or something happens. This one will receive and will be the first one with a return link service from Galileo, allowing an acknowledgement message to the ground troops and search and rescue teams, which is really improving the rescue operations and the morale of all the survivors. It's very important that when you have a problem like that, the people understand that you are identified, you are located, and someone is coming to see you. So this is the full loop of signal, really, in fact, starting from the beacon, number one, going to the satellite, the ground segment, and then, in fact, mission control centers to understand really if this is a true alert. And in fact, with the return link service, you have another, in fact, and this is really new in this rescue beacon world, another flow of information going through Galileo return link service, back to the beacon, and activate or flashing, in fact, some features so people understand. And then this is coming back, so this is a complete loop to the search and rescue team for the search and rescue, the last step, which is number 10. So we do that for all kind of distress beacons. The second project that started, in fact, before, the Helios project is a consortium. So we created a consortium with Airbus, with Air France, with Coba Montana, CNES, for the aviation part. You have also company Scion for the maritime part of it, because this is providing maritime beacons and aviation distress beacon. So this is really this distress tracking product that is new. We are also at the same time participating to the creation of standards, ED622B, part of the ARINC working group. So this is pushing all the industry all together for improved safety and improved performance. So that was funded by GSA, part of a 2020 program as well. So this is a kind of simulation, aircraft, normal flight, you cruise, and if something happens, a distress may happen, and then this is distress tracking. In the past, this would have happened only at a crash. Now, distress happens in flight, and you have several. In fact, every 5 seconds, you have a message which is sent to the satellite, which is brand new. So you have really a distress tracking of the last part of the flight, if you can say that, and then you have post-flight localization. So this is quite new for the industry. Also part of this standardization work, because this is all working in parallel, we are covering the MAF, so Minimum Aviation System Performance Specification, for the RLS in the EuroCAE working group. So this is defining all the processes, procedures, standards to have detailed specification for manufacturers and aircraft manufacturers also. So to understand what is needed, what is robust, show the downlink and improve performance. So this is a work in progress right now. So then this is only this return link that is displayed here on the screen, which is showing the improvement also to the localization. There is also something new on this part, which is the activation from ground. So in the past, the LT was activated only after a distress event. This is a lessons learned of Malaysian Airlines, actually. We can activate an ELT from the ground. If the normal tracking disappear, missing reports, it's called, then you want to locate the aircraft. So you can push on a button, basically, and through Galileo satellites, you activate the beacon and have an autonomous location. And very autonomous, because this doesn't rely on any system of the aircraft. This is only going through the Galileo GNSS loop and then back to the ground segment. So this is a new functionality that didn't exist before. Thank you very much. On time.
Thank you, Christian. Are there any questions for Christian?
Good morning, everybody. I'm Pere Molina. I work in Genomerics. We are a small R&D company in Barcelona, actually south of Barcelona. We are experts in GPS, GNSS technologies and inertial technologies, so we are navigation experts for many fields, basically mapping and cartography applications, and as such, drones is one of our topics. These platforms are really coming to pretty much everything. And here, I'm trying to convey today some messages. You will see that on how or what we are requiring or needing to use Galileo and EGNOS in drones, right? And these are messages for you, from our community, and also for the implementers and deployers of this constellation. So first of all, let me start with technology. These are two types of GNSS receivers, and the first one is probably the most used GNSS receiver in most of the drones. There I mentioned some manufacturers. Actually, these cover, I would say, more than 3/4 of the drone market. And this is a chip. It's very small, that small, low consumption, but it's single frequency receiver. So mainly capturing GPS L1 and Galileo E1 frequencies, which is not bad. because actually it also captures S-bus signals, so EGNOS signals. But this is like the second generation coming. I put future in there, but actually erased it because it's also present, because nowadays there are people integrating this, which is a similar chip, similar size, bit more of consumption, but enabled for multi-frequency. And this is the detail of what we see in the specs of this receiver, already equipped again with GPS L1, and every time we see GPS L1 we have S-bus, so EGNOS in there, but also 2 Galileo frequencies in there. So, first message here is technology is ready. It's us to use it or lose it, of course. So, then after this message, the question is, but how do we do that? How can we get these measurements into our solution? And I will come back to Galileo later on, but let me focus on one, in our opinion, underexploited feature coming from EGNOS, right? And this is what we call navigation integrity. Now, I don't know how many of you guys are familiar with navigation integrity. Let me just post it in one plot. This is the range residual, so the measurement from one of the GPS satellites, actually GPS satellite 27, and this plot corresponds to 2004, so back in time. And you see how the residuals here suddenly, for no apparent reason, they grow, so there is an error coming to this satellite and lasting for at least 2,000 seconds after the satellite is switched off and then the range goes to 0. So this is a slip, something happened to the clock of the satellite, and this is directly something affecting to us, to the receivers, to those computing our position. Now, the problem is that, can somebody warn us about this? Yes, but GPS constellation has the health status of each satellite that comes only or maximum after 2 hours. For the Russian constellation GLONASS is actually after 16 hours. So that's clearly something too much for us, let's say. And now we did some experiment with this, because you might think, like, what is the impact of that? Well, this is again one text extracted from actual faults. This is things that happen already. So problems back in 2004, I didn't know what happened this year, but many things happened. In satellite 23, errors resulted in a range error of 285 meters before the satellite was identified as unhealthy. So what we did, and here's the plot that you have on the right, this is actually a drone trajectory. You see the east-north components and a height. So the drone takes off, goes to somewhere, takes down, so landing, and then again going up and coming back, actually. So think of some, for example, package delivery mission with a drone. And what we did is introducing this error into the solution. Now, you cannot see that. Let me put a zoom in there. That's that tiny gray spot jumping in there up to 40 meters, 60 meters in the horizontal, and 50 meters in the vertical. Bad luck here is actually that the jump on the GPS position goes up, and then your autopilot in the drone will take to compensate this your drone down. So you will jump like as much as 50 meters down. For 6 seconds we did this. I can tell you, no pilot will be happy with that. So, second message here, drones cannot afford these errors. And happily there is a solution. EGNOS is designed to cope with such type of errors, which are integrity errors. Now, far beyond the error correction, identifying that a satellite is wrong, there is another concept related to integrity, which is protection. So giving protection bounds to your solution. Now, you know probably these maps very well. Carmen actually showed one of these. This is an availability map for EGNOS in APV1. And what I'm interested here is to check these boxes here, which is one concerning to protection, the alert limits here for APV1. So these are the numbers. Another concept related to integrity, which is the time to alarm. So the system is designed to warn you in no longer than this amount of seconds. And the final one, very important one, is the integrity risk. So what is the probability you are assuming that beyond these alarms, you're not warned within this time. Okay, so these are the numbers. Now, this is for aviation, this is certified, we all know that very well. But when you come to such a scenario, this is a depiction from a conceptual integration, traffic management integration for drones in Singapore in this case, where you see these drones flying around, crossing buildings, getting close to them, trying to land, emergency situations, paths, going to the ground. You suddenly realize that these numbers might have to change. So new message here, EGNOS integrity is a starting point. It is fine. It provides of some mechanisms which are useful for drones, but they need to be reviewed indeed. Now, doing this is not straightforward. Let's say there's been some initiatives on the past. Let me just highlight two of them which I know well. First one is a pretty old project. It's something that we ruled some time ago. 2010, where 2010 the drones look like this. That's a helicopter, 2 meter long, 75 kilos, made of iron and a gasoline engine. So that's 2010. And we did an exercise with search and rescue operations, so a drone with thermal and optical cameras for search and rescue, which already we had the chance to investigate how to modulate this navigation integrity and tighten it for drones assuming maybe a higher risk. So that's first exercise. There's actually papers about it. Second one is one project that recently closed. It's called Real. This is holding for Airbus EGNOS assisted landings. And basically they did two different scenarios: power line inspection, one of the most used drone applications, professional applications, and firefighting. And now results in a synthesis are saying that we can go very low or lower than RNP 01 for these type of scenarios, okay? So two different exercises. There's many more. There's a lot of now EGNOS, drone exercises around playing with integrity, but these two are in the line of saying, hey, this message of we need to adapt these features, right? Now, many more things that we can do, not just on the GNSS side. Let me tell you about what drone navigation looks like. It actually is a cocktail, pretty heterogeneous with low-cost sensors to deliver your navigation, right? Your position and your attitude when flying. Now, there are sensors like the classical ones, IMUs, baro altimeters, magnetometers, multiple GNSS constellations, as shown before. Other sensors not meant for navigation, like lasers and cameras, which are people already integrating on that. Now, what is that? Yeah. Now, that is telling somehow that we need to cope with this, not just from the signal in space, from the GNSS side, but also on the local side, on the aircraft side. Now, when you check out the definition of integrity risk, you see probabilities, you see faults, and impacts beyond these tolerances. And this, now let me bring it to my side, to our terrain, and to this guy, William Barda. He was a cartographer back in the old times. And in the 60s, he did this theory for first time developing a framework for statistical quality control for geodesy, nothing to do now for navigation, okay? But think about these geodesists guys. They have to merge like a lot of info from many years. This surveyor that did this campaign 10 years ago, different quality with this new national map, you know, they had to put everything together. So there is a well-consolidated framework for blending all this together and measuring the quality out of it. Well, I'm not willing to go through all of these. If you wish, I can go, but I don't think we have time, Carmen. So there's some ways to use these mechanisms to finally blend it and provide alert limits, blending all this cocktail of navigation technologies, which at the end are the core of drones, okay? So message number 4, robustness, integrity. It's the same thing. It's everybody's business, not just GNSS business. Now, final message related to Galileo and the features that bring to drones. Well, indeed, first thing, which is obvious, is the global access. We need solutions that are global all the time. We need drone operations to be available here and there. And for that, Galileo is indeed ensuring this feature. Carmen talked about approaches or how Galileo will bring into these RAIM approaches some features for integrity. Well, this is interesting. Here I put the question like, will we see self-contained integrity services within the constellation? That would be an option. Second part would be what is on the right, a higher number of GNSS satellites. This is again obvious. This is related to a better precision in your solution. Actually, pilot drones like to see the more satellites in there in the screen. They feel safe about it. And this is also related to observability of the errors. Whenever an error happens, the more measurements you have on it, the better you will be able to detect those, of course. Specific type of features for Galileo, I don't know if you know this, E5 Albok, that's a special signal sent from Galileo. This is having very good properties against multipath. Multipath is the effect of rebounding signals that affect your position. Now, when we think on drones going into or within obstacles, a multipath will be definitely an issue, okay? And on the other side, the performance in real time that will come for the next, on the next services deployed by Galileo, like for example the high accuracy service deployed through one signal, which is the E6, and providing real-time accuracy with no other means than Galileo at a maximum of 20 centimeters. So there was a gap now from centimeter solutions based on differential processing and EGNOS, which is 3-4. Now we're talking about 20 centimeters, 1 sigma error. So this is a very nice feature indeed to be used. Authentication of the navigation message. This is more the encryption part. How to protect our drones from hacking and from intentional effects on the drones. This is very important. As well as the commercial authentication service, which is also in line of encrypting, but not the navigation message, the signals itself. So more safety in there. Final table here. This is actually extracted from Spanish regulation. One of the working groups working on the navigation specifications. And as you see here, for the different levels, I don't know if you're familiar with the SOAR analysis, but for the different integrity levels in this, provided, we have different, or they came up with different GNSS error specifications. This is very good. This is a very good starting point, defined by these values, but indeed, they need to be further worked out. Now, final message, Galileo and EGNOS seem in the right position, according also to these stable values, to deliver the aimed performance for drone applications. That was it. So if you have any questions here, now and there, we will do that. Thank you.
Any question for Pere? Please. We will bring you a microphone.
How can GNSS navigation survive signal jamming, especially Galileo and EGNOS?
Well, jamming is one of the another issue, as a spoofing, which was more the one that I was talking about, the hacking of the signals. And so far, I believe, I'm not an expert in jamming. So far, I believe that this is an external attack, and little less can be done when it comes to a total jamming, for example. But multi-sensor, in the case of the drones, it's definitely a weapon to fight this. So being able still to navigate even without GNSS signals would be something that would keep your solution alive, right? The question was, is this realistic for low-cost drones? Generic question. This I don't know. I cannot tell.
Maybe if I can complement. Normally jamming is done on a specific frequency. In the case of Galileo, Galileo is transmitting the open service in two frequencies, E1 and E5, so that if one frequency is jammed, the other one would be working. Indeed, you need to have the two frequencies implemented in the receiver. But as Pere was saying, even the new MoveLogs receiver already is implementing the two frequencies for Galileo. There are even low-cost or mass market receivers that are already implementing dual frequency, available already for mobile phones. The new Xiaomi mobile phones are implementing dual frequency. So we see that this dual frequency is becoming mainstream and used also for drones. And this is a way of targeting jamming. Cool. Yeah. So we switch. Any other question? No? So then we go back to manned aviation. So I would like to welcome Hugo Luengo from ESSP. And Hugo is going to present IFR operations to non-IFR runways.
Hello, everybody. It's good to see some familiar faces today here. My name is Hugo Luengo. I am part of FISSP aviation team, and I'm going to show you one of the projects that we are more proud of, not only for the results received, but also for the interest raised among the users. And we have detected that there is an urgent need for general aviation users. They need to improve their accessibility to non-instrument runways and small aerodromes, and IFR is a solution for them because they are well equipped. They have all of them GNSS receivers, and they are not taking full advantage of them. So just to introduce a little bit the topic, the main actors involved in this project were GSA, which is led by Carmen, and is in charge of enabling the GNSS services, and ESSP that has, apart from EGNOS service provision, also try to monitor new developments and try to tailor continuously their services to the user needs. And as you already know, and I would say that you even suffer it, aviation domain is a highly regulated domain. If we want to implement a new scenario, we want to demonstrate that we have a safer operation. The aim of this operation is to show the results that we have achieved through a cooperation process with the relevant actors in aviation, regulators, general aviation users, and service providers. We focused our project in building a scenario of instrument flight procedure implementation in small aerodromes, where the needs were arising were more related with non-instrument runway and control aerodromes. As I have explained before, the main trigger for this is the regulatory trigger. ICAO state letter, lastly published, has stated a new definition for non-instrument runway that is quite clear. A non-instrument runway is a runway intended for operation of aircraft using visual approach procedure, supporting an instrument approach procedure. The only limit is that we have to limit the decision height until 500 feet. But in small aerodromes, instrument approach procedures can be implemented. EASA additionally has launched a regulatory package that involves not only the aerodrome part, but also has a lot of other developments in flight crew licensing, in aircraft maintenance, and so on, to make an environment that is more proportionate for general aviation users. Furthermore, new basic regulation also have a gap for general aviation. I'm not going to quote it literally, but I want to remark and highlight some of the concepts that are introduced in new basic regulation. We need simple and proportional rules, cost-efficient, flexible, based on existing best practice, and in close cooperation between EU member states. We used all these principles to launch our project. Taking into account as a general aviation strategic objectives, what we did is a complete analysis of the operation, considering the existing regulatory frame in almost all the areas: operational, flight crew utilization, charting publication, or ATS. We also have done a research on which of the implementation solutions that are available or ongoing are more feasible, and it's good to share with the rest of the users. We selected some of the countries. We are aware that there are other countries that have very good solutions, but we selected Germany, France, Switzerland, and we go beyond EU frontiers, and we go to New Zealand that has such type of operation for a long time. What we did is to identify the main enablers and to collect all user needs and try to build some operational scenario, and in close cooperation with EASA inside the all-weather operation groups, to develop a document that tries to collect all these inputs, and we hope that it would be published in the next months, but we are still working with EASA, which is the best channel to make it available for users. Just to give a quick view of the project and the workload that has behind, we have been collaborating with more than 25 different contributors involving civil aviation authorities, users from general aviation, air navigation service providers, and other aviation experts. And we have a workload very high related with regulatory aspects. We have reviewed more than 10 EASA rulemaking tasks. And these developments have been tasked under all EASA Weather Operations Group and have been shared with experts in Eurocontrol RISE and now in this World ATM Congress. Just to show you the main outcomes of this, the main outcome is that EASA and ICAO regulatory framework currently is prepared to support instrument approaches in non-instrument runway or non-ATS environments. What does it mean? The GNSS operation is considered PBN and it is covered by EASA AirOps. Furthermore, the aerodrome do not need to be under EASA scope. That is to facilitate the implementation. I mean, only being under a member state regulatory frame is enough to have these instrument approaches available. ATC is not mandatory. There are other figures that are tailored for this. AFIS, non-ATS aeronautical stations, what is called in USA UNICOM. And furthermore, non-instrument runway is ready to support IFR operation with a limit in the decision height of 500 feet. We have also done some work on our side, and EGNOS services are ready to support IFR operation. We have done some amendments in our EGNOS working agreement, so we are prepared to sign an EGNOS working agreement with aerodrome operator, for example. Here we have the first real implementation case in EU. It is in Grenchen Aerodrome. They have published an LPB minima, and let me see if okay. They have published all these operation principles in an aeronautical information circular to make available for IFR users and also for VFR users how to proceed in this instrument approach. They have a radio mandatory zone around the aerodrome, and the pilot, when is conducting the approach, is continuously reporting their position to other users in an open frequency. So they make blind calls. I am 5 miles ahead the threshold and so on, and they are always and the burn approach only clear for the procedure and give QNH and runway in use. So pilots separate themselves, and there is no problem. Just to make a quick set of conclusion, smooth cooperation between regulators, space users, service providers is needed to launch this topic. I mean, we need that local civil aviation authorities are involved in this process. So it is not easy, it is a new standard, but it is feasible. The document, we expect that it will be available the next month, but we are, as I explained before, we are still working with EASA with what is the best channel to publish it. But we can use all these lesson learned, not only for general aviation users, but maybe for other environments like rotorcraft, in the future drones, who knows. But our message is clear. Go for implementation because it is, you can improve a lot your accessibility to the airport. You are ready, and regulatory framework is ready to support this implementation. So you got any question?
Thanks very much. In the US, I've flown in North America extensively in a non-ATS environment, instrument procedures. I hope that EASA has conducted a safety risk assessment, or will do. There are many examples I can give of occasions where there's been an air prox as a consequence of non-participating traffic unaware that there's an instrument procedure to a non-instrument runway. And I think there's a great opportunity, certainly from a training perspective within the EU, where we have a high, an enormous limitation on instrument procedures for training purposes. I think there's also considerations from a PBN perspective for general aviation pilots. Most GA pilots do not hold instrument ratings and therefore are not necessarily obliged to have PBN endorsements. So there's a lot of regulatory work to be done on a flight crew licensing perspective, but also from the safety case. But I applaud your efforts. This is very interesting.
I think that EASA has done some efforts on this. I I didn't include it in the presentation, but in the general aviation package, they always have what they call the basic instrument routing that allows you to perform instrument approaches. It is a modular training. There are some parts that you still have to do in an ATO, but most of them can be. It is also. It has we are aware that the pilot license is important, and the EASA has done some efforts on it. The basic instrument writing maybe is not the best solution, but it's a good initial point. But of course, US is our reference. General aviation operations there are very common. Their use was on daily operations, and there is no problem, and we have to learn a lot from you. I give the lead to.
Any other question to any of the members of the panel? If not, we still have something for you. We would like to welcome you to the EGNOS and Galileo stand. Our stand is the 1141. We will have now what we call the awards ceremony, where we award the users of EGNOS and Galileo that have done something remarkable during this year in using EGNOS and Galileo, and we would like to invite you to a cocktail in the stand as well. So thank you very much for joining us today.